This is my solution to Paul McWhorter's Pico series, lesson 94, homework. Create a count up binary counter with a button and a reset button entirely in a picoW state machine. As before, the green button is hooked up to GPIO pin 14, red button to 15, LEDs to 16 to 19. In addition, the program will be using a shift right for the input shift direction. Before we look at the program, take a quick look at the bottom here to see the normal setup, the two button pins, and the state machine, and we activate it. Let's take a look at the program. The LEDs are initially off. The OSR is the counter, saved counter, so it's initially 0 to match the LEDs being off. We begin by reading the pin, the two button pins. Because we're doing a shift right, they come into the high order 2 bits of the ISR. GPIO pins 14 and 15 go into the ISR positions 30 and 31. Next we shift it right so that they're in positions 0 and 1 respectively. So the GPIO pin 14 value will be in ISR bit position 0. The GPIO pin 15 value will be in ISR bit position 1. And the shift autofills the remaining 30 bits with zeros. This is all the first half of the debounce. Second half of the debounce is done while we copy the ISR to X, and now we interrogate the value of X. If the value of X is 0, we go back and read another button press, because that means no buttons were pressed. If X is not 0, we want to determine if it's 1, 2, or neither. We query using an instruction that requires Y to be set to what we want. We're looking for the green pin. Well, that will mean the bit values, the low bit values of X will be 0, 1, and then we compare that here, and if that's not true, that means the green button was not pressed. So we would go on to check red to see if the red button was pressed. So if the green button is pressed, we wait for it to be released, debounce, reset the counter to 0, reset the LED pins to off, and then go back waiting for another button press. If this jump had been taken, that means it wasn't the green button. So we come down here, and this time we want to check to see if the red button was pressed. So we do that in a similar way that we checked for the green button. The red button would have 1, 0 in the low order 2 bits. So we check for that with this jump instruction. So if it's not 2, so if X is not 2, that means both buttons were pressed. So we ignore it and go back up to read buttons. If it was 2, we wait for the red button to be released, debounce, and then do the addition as we did in an earlier exercise. Copy the inverted previous value, decrement it, This decrement always happens even if x were 0. The case when x is 0, the x value will become all 1s, but the low 4 bits will be 1s, which represent 15, which is what we'd want anyway, so it's okay. So after we've inverted and decremented, we invert the value back into the counter, copy that to the pins, and then return to read another button. So that's the look at the program. Let's see it in action. So let me run it. Start the program. We'll count up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, back to 0. Let's count up a couple more. 1, 2, 3. Now let's test the reset button. Reset. Let's see if the counting up still works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 0. Okay, that ends the exercise. Thanks for watching.